Question 4, in the way it's written, there's absolutely nothing stopping you getting your calculator, putting a summation button in, 7 take away 2x from 1 to 20. And so the answer is minus 280. But what if the question instead said, show that this sum is minus 280? Then you couldn't use the calculator to do it. So for the rest of them, I'm going to assume that it says show that. So for this one, part A, we can spot that the first term here, when you put a 1 in, is 7 take away 2, which is 5. We can also see that the last term, when putting the 20 in, is 7 take away 2 20s, or 7 take away 40, is minus 33. And n is 20 of them. We're going from 1 to 20. And the sum formula, arithmetic formula, n over 2, the first plus the last. So 20 over 2 is 10, the first plus the last. So we've got minus 28 times 10 is minus 280. So we've done it using the formulas from the previous exercises. In part B, the first one would be 3 times 4, which is 12. The ratio each time we're changing by a factor of 4. And n is 10. And so the sum formula here is a 1 minus r to the n all over 1 minus r. Putting the values in, 12 lots of 1 minus 4 to the power of 10 all over 1 minus 4. Going to be a large number, over 4 million when we tap it into the calculator. Part C, we've got another arithmetic progression here. The first term here, by putting a 1 in, makes minus 6. The last term, by putting 100 in, 200 take away 8, is 192. And we've got 100 terms there because n is 100. So the sum of 100 of them here is 50 lots of minus 6 plus 192, and that gives us 9,300. And D, making sure, sorry, I was looking at the wrong line to start with there. D, we've got another geometric progression. We've got a first term of putting a 1 in there makes minus 7/3. And it says it's going on to infinity. So the ratio each time is another minus 1/3. Our sum to infinity formula is a over 1 minus r. I've got minus 7/3 over 1 minus 1/3. So I've got minus 7/3 over 4/3. I've got an answer there of minus 7/4, if you can just about see that.